Hey guys, let's go over D11. And we need to solve this algebraically and then go ahead and prove it graphically. So what I'm going to do is just copy down the problem below. Y equals x squared minus 8x plus 17. And this other equation is y equals negative x squared plus 6x minus 10. Alright, so this is called a systems of equations because there's two variables, and what we're going to do is we're going to eliminate it. Eliminate one of the variables. Okay, so notice you have both x's and y's, and our goal is to get rid of the y variable. So let's use your highlighter if you have one. Every time we see y, we're going to write x squared minus 8x plus 17. Instead of writing y, we're going to write x squared minus 8x plus 17. That is our substitution. Here, if you notice now, this line has no y variables, and now you can just solve for an x. Well, remember, how do you solve for an x with the power of 2? You're going to have to use solving by quadratics, one of the methods. So, I'm going to draw a line down my equal sign. Now again, you can move this green to the left side. That's what I'm going to do. Or you can choose to move this red box to the right side. Now if I move the red to the right side, you're going to have negative x squared minus negative x squared, which is negative 2x squared. But I'd rather have it to be positive. So I'm going to add x squared here. I'm moving this one, so I'm going to do the opposite, subtract 6x. And over here, I'm going to be adding the opposite, plus 10. So you notice over here, negative 1 plus 1 gives you 0. 6 minus 6 is 0. Negative 10 plus 10 is 0. Okay. So I have a 1 and a 1 here, so this will give us 2x squared minus 14x plus 27. So let's review what we did here. We did the substitution method. And what we need to do next now is basically solve for x. And again, I'm going to solve for x to see if we can do the home run. We can see if we can solve this by factoring. And basically what we did there is we're setting this equal to 0. So that'd be step 3, solve for x. Set equal to 0. Okay, so we have an equal to 0, and now we can see if we can solve this by factoring. A times C is going to be 54. And my B value is going to be negative 14. Let's list out all the factors of 54. 2 times 7, 3, 18, 4, 5, 6, and 9. I think that's all we got. Can I solve any of these problems here by factoring? Does not look like we can. Just double checking the numbers. Okay, what does that mean? We're going to have to solve this by the quadratic formula. Let me double check. That's what we're going to be doing. Well, don't be like me. I made a mistake. And the reason I was saying is because it's not factorable, but what I was trying to say is I should have done something else. Check the discriminant. What is checking the discriminant? Checking the discriminant is using this formula b squared minus 4ac. So my b value is negative 14 minus 4 times my a value, which is 2, and my c value, which is 27. And I get 196, and negative 4 times 2 is negative 8, and negative 8 times 27 is negative 216. And if you subtract those two numbers, you're going to get a negative 20. Okay, what does that mean for us if it's a negative number? It basically means that the discriminant is less than 0. And when this is less than 0, this basically means you're going to have 0 real solutions. Okay. Now this word 0 reals means you're going to have we're going to have some kind of, I'll call it blank imaginary solutions. And we'll talk about imaginary in a second, but the goal is that if you graph this, let's highlight this. You're going to have, the big idea here is you're going to have no intersection. So I should have checked that before even trying to factor. Okay? That's why the factoring over here didn't work. Let's go ahead and graph both of these and you'll see why there is no intersection. Okay, let's have this one in purple. I'm going to see if I can factor it to give myself some x-intercepts and sketch a graph by hand. A times c is 17, and I have negative 8. Two numbers that multiply to be 17. There's just 1 in 17, so this is not factorable. Okay, so it's not going to be a fun one to graph, but let's do it. There's my x. Oops, here's my y. Okay, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Something up there. Okay? So my graph's going to cross the y-intercept of 17. That's what the c value is. It's your y-intercept. So my graph's going to cross this. I want one point on my graph. I just wanted to kind of know if it's on the left or right side. So if I put in 1, if x is 1, f of 1 equals 1 squared minus 8 times 1. So I'm putting 1 for x, and just see what kind of value do I get. I'm going to get 10. So I get 1 comma 10. Okay, what does this tell me? I got another point. Does that make sense? So my graph is probably going to look something like this. Okay, so let's review what I did. I used my c value to get that value, 17. And to get this order pair, to know the parabola went this side on quadrant 1 rather than quadrant 2, I just picked an x equals 1. And I put the x equals 1 into my equation there to get a sketch. And you'll verify that by technology. Alright, let's graph this one. Okay, I was just on a call with a student, And the student was asking, what if I multiplied this by -1? You can do that. And then here, I want to see if we can factor that. And you realize that 2 numbers that multiply to be 10, but add to be -6. I'm only thinking of 5 and 2, which they don't. So this is not fun. And so I have a graph that crosses at -10. 2, 4, 6, 8, 10, -10. That's my C value, right here. Sorry, the original one is right here. And it's a -a value, so I know it's going to graph down. You can plug in a point. Let's plug in -1. F equals -1, because that's my x value that I'm just picking. And you're going to put in for every value of x. I'm putting in the original problem there. We're going to get -1 squared, which is 1. So opposite of 1, -6 minus 10. And you'll get -17. So my graph is -1. The graph is something way down here. Right, -1, -17 is like way down there. But the big idea is are those graphs going to intersect? The answer is no. So let's go ahead and put that into our calculator, and I can show you this by graphing this. You can always use Desmos. I'm using this one called Graph in Calc 83. I'm not sure if it's available for Android, but x, so that's x squared minus 8x plus 17. And then the negative button is down here if I enter. X squared plus 6x minus 10. And then I'm going to press graph. Okay, so here's our graphs. You notice that there's no intersection, so there is no solution for this quadratic systems. See you guys.